This is the first section of Unit 3A, Airbags. In this section, 3.1, we'll be discussing the states of matter, solid, liquid, and gas, and their changes between each other. The solid is the first of the three physical states we will discuss in this section. As seen in the diagram, the particles are closely packed because they have very strong attractive forces holding them together. They can't switch places, they can only vibrate in place, so we say that they have low kinetic energy of motion. Because of their closely packed structure, they have a definite shape and a definite volume, and we say that they are incompressible. We can't push the particles closer together because they're as close as they can get already. The second of the three would be the liquid state. As seen in the diagram above, the liquid particles are more spread out than solid particles, and that's because of the weaker attractions holding them together. Particles are able to move past one another, thus they flow, and because of that, they have an indefinite shape. They take the shape of the container they're in. They do, however, have a definite volume, and they're slightly compressible. What that means is that we, in theory, can push the particles closer together, even though in reality that is generally not the case. The last state is the gaseous state, and as seen in the diagram, the particles are very spread out. They have the weakest attractive forces out of the three, and because of this, they are able to move in rapid, random, chaotic motion. We would say that they have high kinetic energy. Because of their weak attractive forces, they will take the shape of their container, so they have an indefinite shape, and they also have an indefinite volume because they will take up the space that any container gives them. They are highly compressible, and what that basically means for us is that the particles can move closer together, and that's because there is a large amount of space between those particles.
We've discussed the words endo and exothermic before. Now we're going to apply them to changes in state. There are three phase changes that you need to know. The first one is melting. That is when a solid turns into a liquid. The second one is when a liquid turns into a gas. That's called vaporization. And the third one is the direct change from a liquid to a gas, which is the process of sublimation. In all three of these changes, energy must be put into the substance in order to increase the motions of the molecules, thus breaking the intermolecular forces and allowing them to separate from one another. This diagram shows you the three phase changes we just talked about: melting, evaporation, which is a form of vaporization, and sublimation. And notice the arrow at the top says that heat energy taken from the environment will be put into these states in order to get them to change. At the bottom of the diagram, you will see that there are three additional states that work in opposition to the three we've just discussed: condensation, deposition, and freezing. And you'll notice the arrow goes in the other direction. This time, heat energy will be removed from the substances and released into the environment. The three additional phase changes that you need to know is when a gas turns into a liquid, which is called condensation, and a liquid turns into a solid, which is freezing, and when a gas directly converts to a solid, which is called deposition. In all three of these phase changes, we have to remove kinetic energy from the substance in order for the molecules to slow down so that the intermolecular forces can begin to draw and hold the particles closer together. So we will be removing energy from that high kinetic energy state that a gas is in to slow down the particles so that their attractive forces can take hold. We'll do the same thing for the liquid particles, remove some more energy in order for the solid particles to take hold. Here's another diagram reviewing the 6 changes of state and which ones are endothermic and exothermic.
Now we need to talk about the temperatures of the state changes we've just discussed. Freezing point, abbreviated FP, is the temperature at which a liquid turns into a solid. Melting point, abbreviated MP, is the temperature at which a solid turns into a liquid. What you might not know is that the freezing point will be the same temperature as the melting point for a particular substance. Example, Water. Water has a melting point of 0 degrees Celsius. It also has a freezing point of 0 degrees Celsius, or 32 degrees Fahrenheit. Boiling point, abbreviated BP, is the temperature at which a liquid turns into a gas. Condensation point, also known as dew point, is the temperature in which a gas turns into a liquid. Both the condensation point and the boiling point of a substance will be the same. Once again, water, as our example, has a boiling point or a condensation point of 100 degrees Celsius or 212 degrees Fahrenheit. Every substance in this world has their own particular freezing and boiling point. Freezing and boiling points are physical properties, characteristics that describe the appearance of something. Physical properties are a great way to identify an unknown substance.